After understanding the acceleration due to gravity and nature of its freely falling bodies, let us study how these freely falling bodies behave and how this motion of these bodies move in downward or upward direction using Atwood's machine. So the Atwood machine basically consists of very simple things like long vertical support as shown in the figure, and there will be a pulley and the weights will be hanging from the pulleys. So what we basically need here is a long vertical support and a light and frictionless pulley and calibrated metal masses and a stop clock to measure the time and a meter scale. So we can measure time here and we can measure distance here. So use this machine to understand how the tension developed in these strings when you put different masses. One goes up, one goes down based on the value of the mass. So how they act and what is the tension that is developed? Is the tension different in both the strings or how the tension is balanced? So that gives rise to the freely falling body's nature. So let us consider two weights of 800 grams and 900 grams and understand and find out what is the tension developed in both the strings. So when 800 grams is put, from what we understand from daily life also, the lower weight in the balance, it will go up and the higher the weight, it will come down. So if this is 900 grams and this is 800 grams, then what will happen to the 900 gram one? It will move downward and 800 gram one moves upward. That means this has a downward acceleration and lower weight has upward acceleration. If both sides have equal weights, let's say both sides are having 800 grams, then it is a balanced, it doesn't move in any direction. So it means that there is no acceleration. If m1 is equal to m2, then acceleration is 0. So now in order to understand the tension, first we need to see what is the accelerating force that is acting on these weights. So why the acceleration is coming? So when the weights are same, then there is no acceleration. So acceleration is developed because there is a difference in weight. So what is the difference in weight? So the difference in weight in this case is 100 grams. Now what is the accelerating force in the unbalanced weight? One is 800, one is 900. So in the unbalanced weight, the accelerating force is generated because of this 100 grams. So we can find out the accelerating force F is equal to, we know that it is mass into acceleration, and mass here is converted into kg, 100 by 1000 into the acceleration due to gravity is g, which is 9.8. So this force becomes 0.98 newtons. So the 0.98 newtons accelerating force is acting on these unbalanced weights, but it is acting on both the masses. So what is the total mass on which this accelerating force is acting on? 900 plus 800, which is 1700 grams, which is nothing but 1.7 kg. From this, we can find out what is acceleration, because force is equal to mass into acceleration. Acceleration is force by mass. On the force we know, which is 0.98 divided by 1.7. So we get the acceleration with which the weights move is 0.576 meter per second square. Now we'll understand what is the tension in the string. So to know what is the tension in the string that the string is experiencing, we need to take these masses on individual basis. How do we do that? We hold one mass, let's say hold 800 grams and find out what is the force on 900 grams. So when you hold 800 grams and find the force on 900 grams, we will get 900 by 1000 into 9.8, which will give rise to 8.82 Newton. And hold 900 gram and find out what is the force on 800 gram. We will find it to be 800 by 1000 into 9.8 is the acceleration due to gravity. We will get 7.84 Newton. So this 7.84, 8.82 Newtons, these are nothing but the weights. The weights of 800 gram is 7.84 Newton, weight of 900 gram is 8.82 Newton. Now having done that, we know that now you release the strings. So when you release the string, what happens? The masses are accelerating freely. When these two masses accelerate here freely, then the tension will be somewhere between the tension on M1 when you held M2 and the tension on M2 when you held M1. Somewhere in between. So we need to find what that tension will be for each of them. So let's say first consider only one mass at a time. Say 800 gram to find the tension. Say for 800 gram, what is the upward acceleration? Because 800 gram being the lower weight, it moves upward. So what is the upward acceleration in this case? We know that we found out 0.576 meter per second square. Now we know that force is mass into acceleration, which will give rise to 0.576 into 800 by 1000. How did we get this 0.576? We got it from the difference in mass and accelerating force. So by calculating this, we will get this as 0.4608 Newton. Now, this force creates a tension in the string. Since it is 800 grams lower weight, it is going upward. So it is an upward tension in the string. Whereas weight of the mass acts downward, which is nothing but mg. Since it is moving upward, resultant movement is upward. In this case, tension is greater than weight. It means tension minus mg is the force that the string experiences, 4608 Newton, which we found out here. So the tension is nothing but 0.4608 plus, and mg is, we have calculated earlier, which was 7.84 Newton. So which will give rise to 8.3008. Now in the same way, let us find out tension for 900 grams. This is downward acceleration. In this case is also the same thing. 0.576 meter per second square. Here the force is mass into acceleration, which is 0.576 into 900 grams, so 900 by 1000 kg, which is equal to 0.5184 Newton. Now in this case, the tension is downward. Tension is downward and weight is also downward. And tension is less than weight. So we say that mg minus t, mg is the weight and t is the tension, since it is the downward direction, is equal to the force that we got with the downward acceleration, 0.5184. So in this case, the weight is higher than the tension. That's why it's moving in the downward direction. So weight is higher because weight always moves in the downward direction. So resultant movement is downward. So it becomes mg minus t. So mg in this case is 8.82 as we calculated earlier. So we arrive at t as 8.3016 Newton. So what we understand from this problem is the tension on both the strings is the same. Though the accelerating force that has produced the weight, so that weight in comparison with the force on individual masses, when we take the tension on individual strings, we find out that tension in the strings is the same, and that is the reason they will attain an equilibrium once they move the certain amount of distance based on the weight. This happens mainly because the acceleration due to gravity is the same on both the masses.